Hello once again. Welcome to the continuation on the direction or bearing of a vector that I started with you in the first video. In the first video, we started learning about how to find the direction or bearing of a given vector, which we've done a detailed explanation on it, and also we've solved an example on it as well in the first video. And I hope you understood it and you enjoyed the lesson as well. So in this video, I want us to solve another example on it so that you get a better understanding of it. Okay, so I have example 2 on the board, so it means we've already done example 1 in the first video, and I will encourage you to do well to watch the first video, because the first video lays the foundation, the basic knowledge and explanation that you need about finding the direction or bearing of a vector. I've done all those explanations into details in the first video. Okay, so the first video lays the foundation which you need to watch to be able to get a good foundation to handle this session as well. Okay, so do all to watch it so that you can easily handle this one. We are just going to apply the knowledge that we've gotten in the first video here to solve the example that I have on the board. Okay, and please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. Let's go ahead and take a look at the example that I have on the board. Okay, so example 2, it says that find the direction of the vector QR equals to -2, 3. Okay, so we are being asked to find the direction of the vector QR given to be -2, 3. And from the first video, I've explained to you that we need to plot the point or the component of the vector, which is the -2, 3, on the Cartesian plane. Okay, which we are still going to identify it as the cardinal point. Okay, so first let's draw the cardinal point, and we are still going to use it as the Cartesian plane to plot the point -2, 3. Okay, so let's do exactly that. So let me write down my solution and let's begin. Okay, so let me draw my cardinal point. So I have my north, south, west and east, okay, which I've explained to you from the first video that with the vertical line represents the y-axis. Okay, you know from the Cartesian plane, we know that the vertical line is the y-axis and the horizontal line is the s-axis. So it's the same thing. This vertical line is going to be our y-axis and this horizontal line is going to be our s-axis, so that we can plot the component of the vector QR given. Okay, I hope the explanation is clear enough up to this point. So I will label this vertical line as my y-axis. So here is going to be my positive y-axis. Here is going to be my negative y-axis. Okay, I hope you understand and you agree with me up to this point. And here is going to be my negative s-axis, and here is going to be my positive s-axis. Okay, so we are just labeling the horizontal line here as the y-axis, and this is the vertical line instead. Okay, so the vertical line here as the y-axis and the horizontal line as the s-axis. Okay, so now we can go ahead and plot the components of the vector QR on the Cartesian plane. Okay, so I have the vector QR to be minus 2, 3. And you know that the first value, the top value, represents the x component, and the down value represents the y component. Okay, so the x component here is the minus 2. So let's go to the Cartesian plane. So the minus 2, it will be here, okay, which is the x component. So it is not drawn to scale, so you use your imagination to determine where the minus 2 will be. Okay, so for me, the minus 2 will be here, of course. So I have my minus 2 here. Okay, I hope you understand. Then when I come to the y component, it's positive 3. So positive 3 on the y-axis, because this is the y component. Okay, so positive 3 on the y-axis. So my positive 3 will be, let's say, somewhere here. Okay, so positive 3 somewhere here. Okay. So now that we are done plotting it like this, we need to locate the point of intersection. Okay, so let's locate the point of intersection. So you do your little dashes to get you the point of intersection of the point minus 2, 3. Okay, so you can see that they meet here. Okay, so this is my point of intersection. I hope you understand up to this point. And I've explained to you from the first video that look at the vector given. The vector given is QR, meaning that we are moving from point Q to point R. Okay, the starting point is where Q, and we are moving to point what? R. So the first letter becomes a label for the origin. Okay, so now the origin is the Q. Okay, this is the point of intersection, which is the origin, which is going to be Q, because we are starting from Q to R. So the Q, which is the first letter, is the origin. So always you put the first letter as a label to the origin. You use it to label the origin. So this is the origin is Q. Okay, then of course here will be the R. Okay, so this is the vector QR. So vector QR. So this is how to draw your vector on the Cartesian plane. Okay, and I've explained this a lot in the first video. We are applying that same knowledge here. I hope the explanation is clear enough up to this point. Okay, so now we want to find the direction of the vector QR. Okay, so I've explained it to you that anytime you are reading, when it comes to bearing, anytime you are reading an angle, you always start from the north and you read in the clockwise direction. Okay, so for us to get the direction of the vector QR, it means we will read from the north. Okay, so starting here, you read in the clockwise direction, don't forget. So we are going to read from the north. Starting from here, you read up to we end on the vector QR. I hope the explanation is clear up to this point. So now, we want to get the direction of the vector QR. And from the first video, I've explained that we always start reading from the north in the clockwise direction. So we end on that vector given. Okay, so now you have to start reading from the north. So you read till we end on the vector QR. Okay, and that is what is going to give the direction of the vector QR. Now you cannot exceed it. You always end on that line that gives you the vector. Okay, so the vector QR, you can see that this is the line, so you end on it. You can't exceed it. Okay, so you read from the north, so you end on the vector. Okay, and that gives you the direction of the vector QR. Okay, so it means that we need to know the angle which is supposed to be here. The angle which is supposed to be here, let's label it as theta, because if we are reading from here up to here, we know that here is 90. When we come here, it will be 180. Then when we come here, it will be 270. So we need the angle which is supposed to be here to add it to the 270 degrees, then it will give us the direction of the vector QR. I hope you understand. All that I'm saying is that we started reading from the north and we need to end here to get the direction of the vector QR. But we don't know the angle which is here, which I've labeled it as theta. Okay, so, but we know that from here up to here is 270 degrees. Why? Because this quadrant is 90 degrees, this quadrant is also 90 degrees, and this quadrant is also 90 degrees. So 90 plus 90 plus 90, it gives 270 degrees. That is when you read from the north up to the point W, which is the west. But the thing is that we are reading up to here, so we need to know the angle which is here to add to it, then we'll get the complete thing, okay, which will now give the direction of the vector QR. Okay, so we don't know this angle. I've labeled it to be theta, so we need to find it. And how do we find that? We are going to consider this right angle triangle that we've drawn here. Okay, so that's what you are going to consider to be able to find the angle theta that we need. So we are going to consider this right angle triangle. So this right angle triangle, that's what you are going to consider to find the angle theta. Okay, now please take note that the value here, the length here, okay, now from the origin to this point, we know that it's 3. Okay, please follow. From the origin up to this point is 3. Okay, you can see from the board. So it means that from here up to here is also 3. Can you agree with me on that? The length from the origin up to here is the same length from here up to here. So if from here up to here is 3, then it means from here up to here is also 3. So I can put 3 here. Okay, so let me put 3 here. I hope you understand and you agree with me up to this point. Okay, now let's come to this side also. From here to here is minus 2. Okay, now please follow. From here to here is minus 2. Okay, but when we are using the trig ratio, which is the tan theta, to calculate for the angle, we are not going to use the negative value. We are going to use a positive value instead. So instead of negative 2, we are going to use positive 2. Okay, I've explained to you from the first video that the trig ratio that you are supposed to use to calculate for the angle theta, which is here, it is the tan. And I've explained why it is the tan in the first video. Okay, and I'm saying that the negative 2 here, we are not going to use negative 2. We are going to use positive 2 because the negative was just to help us to draw and locate which quadrant that the angle will be in. Okay, you can see that the vector QR is given to be minus 2, 3. Okay, so we used it to draw, to locate that, oh, the angle will be in this quadrant. Okay, so that's all that the negative sign does. Okay, but when it comes to recalculating for the angle, we don't use the negative sign inside. Okay, so if it's negative sign, you ignore the negative and use the positive value. So this side to this side is negative 2, but we are going to use positive 2 when we are calculating using the trig ratio, which is the tan theta. I hope the explanation is clear enough up to this point. Okay, so let's proceed and go ahead and find the angle theta which we are supposed to have here. Okay, so we know that tan theta equals to opposite over adjacent. Okay, this I've explained a lot in the first video. Okay, so now the opposite here is this side. Okay, the side of the triangle which is opposite to the angle theta is called the opposite. So here is the opposite, which is the 3, and the adjacent is this side. Okay, so the part that forms the base of the right angle triangle Okay, so here is the adjacent, and which is the positive 2 that you are going to use, not negative 2. I've explained to you. Okay, so let's go ahead and input the values. So my tan theta will be equal to the opposite is 3 all over the adjacent. You are going to use positive 2 instead of negative. Okay, so anytime it comes to you calculating for the angle, please ignore the negative signs. Don't use the negative signs when you are calculating for the angle. Okay, that's the trick that you are supposed to know. Okay, so let's go ahead. So my theta will be equal to tan inverse of 3 over 2. Okay, and from here you need to use your calculator to be able to get the value of theta. Okay, so let's use our calculator and let's check for the tan inverse of 3 over 2. And that is giving me 56.30993247. And you don't need to write everything, so I've explained to you that leave it at 3 decimal place. Okay, so I'm having 56.309. Okay, so I'll leave it at 3 decimal place, then bring your degrees. Okay, so this is the angle theta. Okay, here. So now we know that the actual direction, we always need to start reading from the north up to this vector QR. That will give us the actual direction of the vector QR. So now we know that from here to here is 270 degrees. So we are reading from here up to here. So if here to here is 270 degrees, then to know from here up to this point, we just need to add the theta that we found to the 270 degrees, and it will give us the direction of the vector QR. I hope the explanation is clear enough up to this point. The direction of the vector QR is simply reading from the north here up to the vector QR here. Okay, and we know that from here up to this point is 270 degrees, and I've explained that to you. So we just need to know the angle which is formed here to add it to it, so that we'll get the direction for the vector QR. Okay, because we need to read from the north up to reach on the vector QR, then it will give us the direction. Okay, so I'm going to calculate my direction of vector. So direction of the vector QR will be equal to 270 degrees plus the angle theta. I hope you understand up to this point. Now we know the value of the angle theta, so let's input it. So my QR will be equal to, so direction of QR will be equal to 270 degrees plus the theta is 56.309 degrees. Okay, so let's use our calculator to see the final answer that we'll get. So 270 plus the 56.309 degrees. It's going to give me okay, so when you add it using your calculator, this is what you are going to get. Okay, so you get the direction of the vector QR to be 326.309 degrees. Okay, and you can round it to the nearest whole number. Okay, which will be the direction of the vector QR will be equal to 326 degrees. That is if you run it to the nearest whole number. Okay, so this is the direction of the vector QR. Okay, so I hope the explanation was clear enough and you understood it as well. Please don't forget to like the video and also share them after watching. And if you are watching for the first time, please do all to follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we solve other examples on this. Bye bye.